So continuing with advanced Excel, next we will have a look at scenario analysis. Scenario analysis is helpful for the organizations when they are planning for the future, because see, any organization which is planning for the future, they are not 100% sure what is going to happen. So they want to be prepared for every situation. So in this context, scenario analysis can be used. Now, the data that you see on your screen, there are three situations. Let's suppose there is a company which has forecasted the data of next year. So they have a data which is base, then they have a data which is worst. It means that the things don't go planned, the things don't go as per plans, and a company does not perform well. And then we have the best situation, which is in the future everything will go as per plans of the company, or things can get even better. So it will be a very good year for the company. So if we look at the base, what data we have is we have a product. These are various products of the same company: product A, product B, product C. Then we have sales of the company for the various products, and then we have the profit margin for that particular product, and then we have the amount of profit. How we have calculated amount of profit? Simply by multiplying sales by profit margin, we get amount of profit, and we have added the profit of all the products, and for the base year it is coming out to be 56,310 rupees. Now in the worst case scenario, the products are the same, the sales is the same, but there is a huge shrinkage in the profit margin. As you can see, in the base year, product A had the profit margin of 20%, but in the worst case scenario, it has only 5% of profit margin. And same thing goes for all the other profit margins. In the worst case scenario, all the profit margins of the worst case scenario are much lower than the profit margin of the base case. Now coming to the best, this is when the everything goes as per planned, and even a lot of positive things happen for the company and they perform very well. So the products are the same, sales is the same, but profit margin has increased drastically, right? There's a mistake over here. Profit margin, let's say we can make it 25%. So in the best case scenario, the profit margins are much higher than the profit margin of the worst case scenario, and a bit higher than the profit margin of the base case scenario. So now the company wants to know that how much of total profit it will make in the coming next year if there is changes in profit margin, right? If you are supposed to change these profit margins of the worst case scenario and also the best case scenario, then what will be the total profit in that case? This can be calculated very easily with the help of scenario analysis. So let's begin the exercise of scenario analysis. You will find scenario analysis in data, then what if analysis, and here you have scenario manager. So all the situations were added. I'm just going to delete them so that I can tell you from the very beginning how to go about things. So we have three scenarios: base case scenario, worst case scenario, and best case scenario. So we will be adding all these three scenarios in our scenario manager. So first of all, we click on add, then we give the name to the first scenario, which is the base. As you can see over here, base is the name of the first scenario. So we have named it base over here as well. By changing cells, which cell's value is going to change? The profit margin, right? The profit margin cell's value is going to change. Now it shows the profit margin in points. So basically 20%, as you can see, of product A is zero point 0.2. It's the same thing. 25% is the profit margin for product B. Over here it is 0.25. So essentially we have the right data now. We can click on OK. So now we have added a scenario which is base case scenario. Now let's add the worst case scenario when everything goes wrong for the company. What are the cells that will change? The profit margin will change, and then we click on OK. Now we can change the values over here. Let's say that for the product A, the profit margin was as low as 0.02. For product B, the profit margin was very low. Let it be 0.005. And then for product C, let's make it 0.035. And rest of the profit margin remained the same in the worst case scenario. So we hit OK. So now we have the best case scenario and the worst case scenario. Now let's add the best case scenario. Let's name it best. What are the cells that will change? The profit margin cells will change. And now click on OK. Now it is asking us whether we are willing to change the profit margins or not. Let's say that we receive information that when everything will go as planned, product A profit margin will be 30%. Product B profit margin will be 37%. And product C profit margin will be 29%. So now we have added the scenarios. Now let's look at the worst case scenario. So you just click on the worst case scenario and you hit show. As you can see, the profit has declined. Why it has declined? The reason being that the profit margin of the first three products were reduced. So that's why the total profit has also reduced. Same thing we will do for the best case scenario. Note that the first three values we have changed when we entered the best case scenario. So the profit margin has further increased for the product number A, B, C. So when we hit on show, again, like whatever the profit margin that we entered in the scenario, that has been entered over here, and our total profit is 80,140 rupees. So this is how you perform scenario analysis, and you can look at the base. If everything is normal, everything is okay, then the company will make 56,310 rupees. If everything goes wrong for the company, then it will earn a meager profit of 25,735. And if everything is even better than planned, then the total profit will be 80,140 rupees. So these are the three scenarios, and we now know that what will happen in the case of worst case scenario, what will be the total profit, and what will be the total profit in case of best case scenario. Now let's come to another advanced technique which is known as the correlation. Correlation is a term which signifies what is the kind of relationship or associationship that is there between two variables. That is correlation. And the value of correlation can be anywhere from +1 to -1. It can be even 0 as well. So the range of correlation value is +1 to -1, with +1 being high correlation, high positive correlation, we say, when we receive the value of +1. And if we get the value of -1, highly negative correlation, we say it, right? So let's apply correlation in this data. The question is that we are looking to solve is there any relationship between market share and total profits? So over here we have a company's market share, and over here we have the total profits earned by the company. And the question that we have to answer is there any relationship between market share and total profit? Like, is it so that when the market share increases, the total profit also increases? So such kind of questions do come to mind. So we can use the correlation function to find out what kind of relationship exists between market share and total profit. So we first of all type is equal to, then we type CORR, and here we have the correlation function. Double click on it. Now it is asking you for data, array 1, array 2. Array 1 is our market share data, comma. Now it is asking you for the array 2 data. You enter the array 2 data, you close the bracket, and you hit enter. As you can see that the value of correlation is 0.96, which is very near to +1. So we can say that there is very high degree of correlation between market share and total profits. So correlation basically tells you the level of association or the level of relationship two variables have. And in the example that we discussed, market share is the first variable and total profit is the second variable. And the result is correlation is 0.96, which is a very high correlation. That means that there is positive relationship between market share and total profit. Next, come to regression. Now, regression is a very helpful tool if you are looking to predict anything. What basically regression does is, based on the past data, it tells you what may happen in the future. So this will become more clear once I explain to you the data that we have. We have data of 2015 to 2022. In a city, we have total number of colleges. So in 2015, the total number of colleges in the city was 4. In 2016, the total number of colleges were 3, and so on. And there is a computer shop which is recording how much of computers were sold. So in 2015, 23,000 computers were sold. In 2016, 21,000 computers were sold, and so on. Now, if someone asks you what will be the number of computers sold by shop A if in the year 2023 total number of colleges is 16, right? Look at over here, total number of colleges, we have different numbers 4, 7, 8, 5, and when there were 4 colleges in the city, then the number of computers sold was 23,000. So the question basically asked to us is, if in the city total number of colleges become 16, then what will be the total number of computers sold by shop A? So we can do this by regression. Now in regression, it is very important to understand two things. First thing being the independent variable, and the second thing is dependent variable. So dependent variable is the variable whose value is depending upon the independent variable, right? So over here we have two variables. Total number of colleges is the first variable that we have, and number of computers sold by shop A, that is the second variable. Now total number of computers sold by shop A will be our dependent variable, right? Why? Because number of computers sold by shop A depends upon the total number of colleges, right? Students come to college to study and then they buy computers to help them in their studies. So computers sold, the number of computers sold is depending upon the total number of colleges, right? But the total number of colleges is not depending on number of computers sold by shop A, right? Doesn't matter how many computers shop A sell, does it, will it lead to increase in change or change in total number of colleges? No. But if the total number of colleges change, then it will have an impact on number of computers sold by shop A. That's why the dependent variable will be number of computers sold by shop A, and independent variable will be total number of colleges. And the question that we have been asked is, if there are 16 colleges, then what will be the total number of computers sold by shop A? So we will find out the solution to this question by using regression. So we go to data, then we go to data analysis tools. Now we have to search for regression over here. Here it is, regression. Click on OK. Now it is asking you for some of the data to be entered into it, right? It is asked, first of all, see what it is asking you to enter. Input Y range, input X range. So we should know which of the range is the Y range and which of the range is the X range. Now the Y range means the dependent variable. Please remember that. So Y range is our dependent variable. So what was the dependent variable? It was number of computers sold by shop A. We select that. Next, it is asking you for number. Input X range means the independent variable. Now, what was the independent variable? Total number of colleges. So select the data of total number of colleges. I think it will be better if we include the entire cells. Let me just correct it. Now, when we talk about input Y range, let's take label as well. Number of computer sold by shop A is the label. So we select the entire data, and over here we start from total number of colleges, and we have selected the entire data of total number of colleges. Now it is asking you whether the data in the input Y range and the input X range has labels. Yes, so we will click on it. What is the label? Y range has the label number of computers sold by shop A, and X range has the label total number of colleges. Now it is asking you for the output range. Output range means where it should show the results after running the regression. So we can select it on any location. Let's say we want it here, which is G5. So the results will be displayed in G5. And next we click OK. So now we have the results of the regression. Some of the important things, since there are a lot of values you can see on your screen, the important values would be R squared. R squared value is 0.63, which shows that there is a relationship between total number of colleges in the city and total number of computers sold by shop A. Next, what we do is we will find out the regression line. Now, to find the regression line, we need to insert some charts so that we can easily find out the regression line, and we can then find out that if there are 16 colleges, how many number of computers will be sold. If we select this data, and we go to insert, then we choose a particular chart. Let's say we choose this particular chart, which is a bubble chart, 3D bubble. Now over here you can see the relationship in a graph in the bubble chart. Over here you can see number of colleges, right? And on the vertical axis you can see the total number of computers sold, right? So this graph is representing the relationship in between total number of colleges in the city and the total number of computers sold by the shop A. Now we can also enter the trend line, but what basically we are interested is in to display the equation. So we click on over here, display equation on chart, and you can see now that we have the equation. Let's drag it down so that we can see it. So this is the regression equation. Y is equal to 300 3075.6x plus 17,239. Now let me explain to you what this means. Regression equation is this particular equation which you see is telling us that if we enter the total number of colleges in the place of x and we solve this equation, we will get the y. And what will be the y? Y will be the total number of computers sold by shop A. So let's just calculate it. 3075.6, it has to be multiplied by what was the total number of, okay, I'm just trying to move this here. For now, just remove this so that we can move the graph. Yeah, this is what I wanted. I just wanted to see what is the total number of colleges. So 16 colleges. So if there are 16 colleges in the city, how much of computers will be sold by shop A? So what we do is we type is equal to, then we take the this value, which is 3075.6, 3075.6 multiplied by x. Now what is x? X is the independent variable, and the independent variable over here is total number of colleges. So we will enter over here 16 because we are trying to find out what will be total number of colleges, what will be the total number of computers sold in case there are 16 colleges in the city. So 3075.6 multiplied by 16 plus 17239, and we hit enter. So this is the value we are getting, 66,448.6. So if in the city there are 16 colleges, then the shop A will be able to sell 66,448.6 computers. So as you can see, regression is very useful when we are trying to find out a future value of a variable, right?